So in this video, we will look at the characteristic vectors of edge dislocation line. So here you can see a three-dimensional picture of this plane of atoms. Earlier, we had discussed about edge dislocation line. Okay, edge dislocation line. Okay. See, we have seen the edge dislocation line has the missing bottom half of extra half plane. Okay, extra half plane. We will call that a line defect. We have seen why we are calling it a line defect, or we have seen that this edge dislocation line is the separation between no slip and slip region. So there are two ways of approaching the edge dislocation line. So here you can see that here. Uh, so 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 this is your first plane of atom, and here the bottom first plane of atom. So this is the second plane of atom here. This is third, this is four, this is five, and this is six. You can see here this is two, this is three, this is four, this is five, and this is six. So you can see that the first top half plane of atom uh, is flipped. Okay, it is pushed. We have seen that in slip, and it rejoins with the bottom half plane of atom, and the top half plane, that is second plane. Top second plane is joining with third plane, and the top third plane is hanging here, and the this bottom portion. Okay, this missing line is called the edge dislocation line. So in a way, that is the separation between. Okay, if you draw that, so this dislocation line will give you the separation between slip and no slip. Okay. You can see that the slip occurred up to here, and after that there is no slip. So this is one way of approaching the edge dislocation line. Now we want to find what are the various characteristic vectors. Okay, characteristic vectors associated with this edge dislocation line or slip or edge dislocation line. Okay. Now, so let us draw the slip and no slip region once more. Okay, this is the okay. So this line, that is the separation between slip and no slip region. Okay, um, that is the edge dislocation line, and this is given by the tangent vector t. Okay, tangent vector t. So it is the definition of this vector is the unit vector that is parallel or tangent to the dislocation line. Dislocation line. Okay. This is how you define. This is the characteristic vector associated with a edge dislocation line. So it's defined as a unit vector parallel or tangent to the dislocation line. So this vector gives an orientation to the dislocation line. You can see that this okay, so this tangent vector is into this half plane of atom. So that is why I have shown like this. Then you have the Burgers vector. Okay, this is the Burgers vector. This gives you the magnitude and direction of slip. Okay. So this gives you the magnitude and direction of the slip. So you can see that here the first plane of atom is shifted to the right side. So this is the Burgers vector. Okay, this gives you, so there is the total magnitude is the interatomic spacing or the interplanar spacing. Okay, so here in this for particular slip, this is the interplanar spacing or interatomic spacing. So sometimes the slip may be twice or thrice. Okay, this much times of interplanar spacing. For this particular case, the Burgers vector, the magnitude is the interplanar spacing, and here the magnitude is the direction is towards the right direction. Mm, So this P vector, this can be called this is given the name tangent vector, tangent vector or line vector. This is the name given to this uh, unit vector that is parallel to the dislocation line.